Mm-hmm.
Okay. Alright, so the first thing that we're going to get started with is I want everyone to think of what they might know about velocity or speed and just write something down on the board. It can be anything, whether it's a formula, a fact about it, something that it's like related to, anything like that. I'll share a marker in my pen. And if you guys can, try to each write down something else. You're welcome to talk about it if you need to, or try to write something different than one another.
No.
No. Is it speed? Okay.
It's okay if you're wrong or anything. We'll go over it anyways. Just try to think of something. We'll go over this after we're done with the prompts and papers that we here, probably could have honestly left that there. Alright, we'll see. Alright. So I'm going to pass this out. And then I want us all to go over it. Well, we can answer like we usually do. That's on the class. What do you want?
No thanks.
Alright.
I like your rings.
So it's called Following Jack, and what I'm going to do is I'm going to read the prompt with you guys. I'm going to give you guys a minute to go ahead and think about what you think your answer will be to the prompt. It says Josie and her little brother Jack are walking side by side eating ice cream cones. Josie stops to talk to a friend. While she's talking, Jack's ice cream cone starts to drip at a steady rate as Jack walks away. When Josie finishes talking to her friend and realizes that Jack is no longer next to her, she looks down and notices these drops of ice cream on the ground from Jack's ice cream cone. So that's the diagram right there. It's supposed to be explaining this right up here. And it says Josie needs help figuring out how Jack was moving or walking while she was talking. If Josie follows the drips, what can they tell her about Jack's motion? Circle the answer that best shows how Jack moved or walked while Josie stopped to talk to her friend. So you guys just take a minute to think about that, pick an answer, and be ready to explain why you chose your answer. Okay, is everybody done? So we can just go in order and start over here. So let me know what you guys got.
I said C.
Okay.
So at first, they're walking side by side, so it's like slow, and then he starts. Yeah, Jack walks away, so obviously when he speeds up, it's going to go faster, and it says that the drip shows that Jack starts walking slowly, and then she stopped. He kept walking, and he walked faster, and continued to walk at the same speed. It says steadier.
Okay. And you're pretty close. I'd say the only thing that's wrong about that is that it has to do with after he's already walked away. They're not still walking side by side during the diagram. That's just Jack walking by himself. And then she comes back and she's like, okay, how was he walking? But you are right. It does start off with him walking slower and then increasing speed. But at the end, we'll go over that after everyone else gives me their answers.
I said C2 because the dots are really close together in the beginning because he's walking slower and there's less space between the drips, so then he starts to walk faster and the dots are spread out evenly because he's walking at a steady speed.
And y'all might need to speak up because of that fume hood just to be captured on the recording, okay?
What did you get?
I put C2 because the drips are really close together, so he's walking slower. And then it says that he was walking at the same speed, so they start to like even out as he goes.
I said the same things.
Okay. So we all pretty much came to the same conclusion. Everybody got it right. The answer was C. And we all said that when the dots are closer together, that means that he's moving slower. The only thing is, why? Why would that mean that he's moving slower when the dots are closer together? Or when they're further apart? Or like when he's at the constant speed? Like, can anyone explain that to me? What that means? If not, I can tell you guys. If you guys need help, just let me know.
I'll try. I think the reason that they're so close in the beginning is like when he is walking slower, like the drips, it's not that they're dripping faster, it's that he's not moving as fast for them to spread out.
Exactly.
So when he starts moving faster, like they're still dripping at the same speed, it's just he's walking faster so they're able to spread out.
Exactly. That's right. I want to show you guys. I left it in my backpack. Real quick. So these the pasta. That's all I had in my house. Is going to represent the drips from Jack's ice cream cone. So I think it's just easier to get like a visual of it, obviously. So if you guys are just, I mean, I guess you can get up with the camera. I just kind of need space to show you. So like like she said, each drip is dripping at a steady rate. It says that in the problem. So let's say I'm going to drop one piece of pasta for every second, but I'm going to increase and decrease my speed, and we're going to see what it looks like when I drop the pasta down. So if I'm walking really slow, okay, it's like 1 second each, we'll see, like, oops. But if I'm walking fast and still doing it at the same rate, they're going to be a lot farther apart. And I can do it again if you guys need me to. But you see, as I increase my speed, each piece of pasta gets farther apart, but when I was walking slow, they're a lot closer together. And that's how the diagram looks on a piece of paper. Now what I want you guys to do is I want you guys to draw a diagram of your own. Can I have a volunteer try to do, like, walk, and we'll try to guess what their speeds were. You have to turn around. No one's going to watch them walk, and then they're going to drop it, and then we're going to have to see if we thought they were increasing speed or decreasing speed or walking constantly by looking at the pieces of pasta. So you'll draw a diagram just like the one on your paper, like with the dots.
Thank you.
Mm-hmm. It's probably easier to keep a handful of them instead of pulling them out of the bag. Alright, and then you guys will look the other direction because we don't want to watch her because then we'll know if she's increasing her speed or decreasing it. So you guys just look the other direction while you can do whatever you want. You can start walking really fast at first, you can walk at a constant speed at first, or slow down, it doesn't matter. Okay, good. Now you guys can turn around and look. Yeah, that's good, that's fine. Alright, so can you guys tell me what you notice about each drop or pasta noodle? Like where they might be closer together or where they might be further apart?
We're closer in the middle.
Okay, so if they're closer in the middle, what would that indicate to us?
She was faster than slow down.
Good job. Alright. So that was pretty easy. You guys did a good job with that. You guys, I guess, can draw it out what the pasta noodles would look like if